Welcome back. In this video, we will explore what pins are and how they can be used to connect external input and output hardware to our edge device. Let's first look at an edge device, and then we will dive into what the different pins are on these devices and understand their roles, types, and connectivity options. The edge device that we are looking at is again the Arduino Nano 33 BLE Sense, and we took this image from their datasheet. Datasheet is a document that contains information about the edge device, like the microcontroller unit it has, the device's memory and storage numbers, the sensors it has and their specifications, its power requirements, its operating temperature range, and much more. The datasheet is used to learn more about the device and see if it fits our application use case. If you are interested, we will attach the datasheets for a few popular devices in the resource section, and you can check them out. Coming back to this diagram is known as the pinouts diagram or the connector pinouts diagram, and it shows the different pins available on an edge device. Pins are those small metal points on the edge of the device. They are used for connecting the microcontroller to other devices or sensors. Not all pins look the same, though. Some have headers, which are like extending arms that make it easy to attach wires and components. Others are castellated, which means they have notches that allow the pin to be soldered directly to a surface, facilitating smaller and often more permanent installations. There are several different types of pins on an edge device. First, let's talk about the power pins. Power pins are used to supply the power needed from external sources, like batteries or adapters. The ones to look out for are the V-in, 3V3, 5-volt, and ground pins. V-in, as the name suggests, is an input power pin, which is connected to a higher voltage, like 5 to 10 volts. Note that when the power is supplied to the board with this pin, the USB power is disconnected. Also, always remember to give a voltage amount less than the voltage limit to prevent damage to the edge device. Next are the 3V3 and 5-volt pins. These output stable regulated voltages of 3.3 volts and 5 volts and are used to power various external input and output components. And finally, we have the ground pins, which complete the circuit by providing a return path to the power supply. Those were the power pins. Next, we have the digital pins, which are used for digital signals like the on or off states, and are thus perfectly suited for LEDs, switches, or digital sensors. These pins on the right in the diagram, starting with capital D, are the digital pins. There's also D13 on the top left, though that is connected to the inbuilt LED, so it is recommended to not use it for external devices. The pins on the left, starting with the letter capital A, are the analog pins. The A-ref pin is for the reference voltage for analog devices, and we will look at it a little later in this section. For now, just understand that it is used for analog devices. These analog pins, the ones starting with the letter capital A, are used for reading variable signals, or readings from sensors like temperature, humidity, and light. The signal isn't just on or off. For example, a temperature reading can be 10 degrees, 15 degrees, 20 degrees, or for some parts of Asia, even 40 and 45 degrees. They can also be 10.5, 15.2, or 20.75 degrees, and so on, depending upon the resolution of the sensor. These analog values or signals are converted into a digital form for the microcontroller or the processor to read them, using something known as an analog-to-digital converter, or ADC. And we will be discussing ADCs in detail in a separate video right after we finish this discussion on pins. This video has been a little long, so let's do a quick recap. The first type of pin that we discussed were the power pins that are used to power the board and peripheral devices attached to the board, like LEDs, sensors, and switches. The second type of pin that we looked at were the digital pins, which are used to connect to devices which have only two states, either on and off or low and high. In voltage terms, this can be 0 volts for low and 3.3 or 5 volts or VREF of the board that you are using for the high. For our Arduino Nano board, this high is 3.3 volts. This information again is available in the datasheet. Examples of digital devices are LEDs and switches. The final type of pins that we looked at were the analog pins, which are used usually for sensors and other devices like potentiometers. These give back a range of values which are converted into a digital format before being used. There is another type of pin called the PWM pin, which is also marked on a pinout diagram, either separately or by using the wave or the tilde signal. For our Arduino board, all the digital pins can double up as PWM pins, and this is why you can see the tilde symbol before each digital pin on this pinout diagram. Let's discuss what this pin is and what is it used for in the next video. See you there.